our objective is going to be to understand the term causation. Oops. Why is there still yapping going on? Enough. Understand causation. Understand the difference between correlation and causation. Just because they start with the letter C, end with shun, they're not the same. Okay, so let's talk about what is causation. Anybody have an idea what causation is? It kind of tells you in the word. Brian?
Something about some kind of cause?
Yeah, we're looking for a reason why there was this relationship that existed. Okay, so that's what causation is why is the reason, what is the reason that there is some sort of relationship, okay? Sometimes it doesn't really have an effect, and that's where it gets a little weird. So I'm going to teach you also one more thing. This is interesting. I've never heard this term myself. We're going to learn about a lurking variable. Ooh, that sounds fancy. A lurking variable. Okay, so here's what happens with a lot of people. They look at their scatter plot and they see that there is a positive trend or a negative trend or no trend whatsoever, right? There's no correlation, or you have a positive one or a negative one. And so correlation, even though it may appear to exist between the variables, meaning we have that positive trend. Lexi, we're not eating in class, so we got to knock that off. Oh, so you're just chewing in my class.
I gave her some of my donut.
Okay, right now, we're not having snack time. Okay, so let's focus in on what we're supposed to be doing. We have to be cautious that causation which is a reason why something happened. Okay, and that's what people are constantly trying to do, is they're trying to find a cause for the way that the data laid out. And this is why researchers ask these questions. That's why they gather data. They're trying to look for the cause, so that's what the whole point is. They can go get money. They can create some sort of big program, and they can address the issue that's there. Okay, and we've talked about how sometimes the things that they're, wow, I heard something weird on the radio the other day. Some of the money that our government spends on looking for relationships, and it was something so like, are you kidding me? I can't remember. Shoot. You listen to talk radio and you hear some really crazy stuff sometimes. Okay? So, if a correlation exists, whether it's positive or negative, whether it's strong or weak, if a correlation exists between two variables, that does not necessarily mean that one causes the other. Okay, so let's write that down. While a correlation may exist between two variables, it doesn't necessarily mean one causes the other. So if you think back to that graph we had done for number 6 on the independent practice, where it was height and weight. Let's see, who did they have height and weight of? Football players in college football team. Your height doesn't cause your weight, right? You had some small guys that weighed a little bit. You had some taller guys that weighed a little bit. And you had some kind of smaller guys who weighed a lot. And then you had some really tall guys that weighed a lot. So your height doesn't determine your weight, okay? What determines your weight on a football team? Your position, right? Okay, if you're a quarterback, you don't want to be a 400-pound quarterback. I had to laugh during the UCLA game the other day. They were close to the goal line, and they wanted to score the touchdown. They brought in like 600 pounds between two guys. I mean, these beef, like sumo guys, standing at the line. And, I mean, they were Mack truck. Nothing could get through them. They were just going to, nobody was going to get through. They were going to get the goal. And I just had to laugh. The broadcasters were laughing. They brought in 4 guys, 2 of which together were 600 pounds. Yeah, exactly. Yeah. And that's what special teams are all about, right? We have the special situation guys. We need you to do a job. So that's what we're talking about. It's the position that determines the size on a football team, right? You're not going to have heavy-set quarterbacks because they got to be light on their feet. And as you've noticed, like UCLA, I'm going to talk about UCLA all day and all night because that's the team I watch. But Huntley, that guy runs. Huntley gets a lot of yardage, and he scores a lot of the touchdowns because he's looking, his guys are blocked, defense on the other team is doing an amazing job, offense is stymied, they don't know what to do. Huntley just runs, okay? He can't be 300 pounds and run like he does, okay? This is impossible. But you can't be skinny in football because you get killed, right? So you gotta have to have a balance, okay? So there is, even though there was a positive correlation, somewhat weak, between height and weight for those football players, the taller you are does not mean the heavier you get, okay? Now, as kids, the taller you are, you do tend to put on weight because you're growing up. But you hit a point where you get your weight and you kind of stay around that weight for the majority of your life. So it's just a process of you're growing, and you have to naturally, if you stayed, okay, let's say you're 1 year old and you weigh, you don't weigh 2 pounds at 1. Oh my gosh. Holy crud. Let's say you weigh 15 pounds, 20 pounds. When you're 4, you better not still weigh 20 pounds, okay, because you've grown. And if you weigh 20 pounds and you're 4 years old and 3 years have gone by, you're a sick little kid. You're skeletal, okay? So it's natural for us as when we're kids to put on weight as we get taller because we're getting older. So really the correlation is, or the causation isn't the height causes the weight, it's the age causes the height and the weight. But there's other factors that causes the weight, like poor diet, right? Okay. All right. So here we go. Here comes that, what the heck are they talking about, this lurking variable? Now, I find this word kind of disturbing because somebody who lurks kind of is a creep. Yeah, like a stalker, exactly. A stalker variable. Okay, so what I just said, height and weight don't have, one doesn't cause the other. What really is a cause for children for their height and their weight increasing, both increasing, is age. So age, in that example, is called the lurking variable. It's not mentioned in the study, but that is the contributor to that increase in height and weight, okay? So let's see how to describe that. So a lurking variable is a variable that is not being considered. So it's not the bivariate data. So it's a variable that is not being considered that may, that may increase or decrease the result of other variables. So the two that are in the scatter plot. Okay, so I'm going to read a story to you guys, and based on this story, we're going to do a couple different things, and we're going to determine whether it's a positive or negative correlation, and we need to explain whether the correlation is a result of causation or a lurking variable. Okay, so here's the situation: the brain's amygdala connected to social behavior. So an almond-shaped part of the brain called the amygdala has long been known to play a role in people's emotional states. Now, scientists studying the amygdala have discovered a connection between its size and the size of a person's social network. The scientists used a brain scanner to determine the size of the amygdala in the brains of 58 adults. They also gave each person a survey that measured the size of the person's social network. After analyzing the data, they found that people with larger amygdalas tend to have larger social networks. So by social networks, we mean Instagram, Facebook, Twitter, okay? In the old days, MySpace, which I don't think exists anymore. Do you?
I actually do have a MySpace,
Okay.
but I never use it.
All right. So we've got an amygdala, which is part in the brain. Did I spell that right? Yep.
Do we have to write this?
Am I writing it?
Yes.
Then I would believe you would be writing it. So amygdala is a small part of the brain that plays a role in emotional states. So, plays role in a person's emotional state. Okay. There was a study done with 58 adults. Okay. There was a connection that said the larger the amygdala, the larger the person's social network. And again, we discussed that could be things like MySpace, Facebook, Twitter, Instagram, all those, somehow you're connecting with people. Okay? So the question is, what kind of correlation, based on this data, exists with these two variables? Chris. No. What kind of correlation?
Oh,
Positive, negative, none.
positive.
Okay, according to here, larger, larger, if they're both going in the same direction and they're increasing, that means that's a positive correlation. And I'm trying to see if it said anything. Found that people with larger amygdalas tend to have larger social networks. Now, so I cannot determine whether that's a strong or weak correlation, just that there was this tendency that the larger your amygdala, the larger your social network was. Okay. Do you think the larger amygdala, or let's see, put it this way, do you think that the larger social network created the amygdala to become large, or caused the amygdala to grow? so that it was larger? Okay. Or do you think that people who were born with large amygdalas naturally are going to have a larger social network? Okay. The question is, it's kind of hard to make that judgment. So causation may be possible, or is possible, but we're not sure of which variable caused which variable. Okay. So the question is, does the amygdala have the ability to grow? Or for me, this is what I'm thinking, could be a lurking variable. Because you have a large social network, do you think that would help you handle stressful situations better than somebody who has a small group of friends?
Yes.
Okay? And that could be the reason that somebody who happens to have more people that they can go to have a stronger ability to deal with stress. Now, does that create the amygdala's size to increase? I don't know. So the lurking variable to me could be more friends help deal with stress. Okay. And sometimes the only place that some of us have to go is online to our social network because of whatever circumstances we have at home where we're isolated and we can't get out or get somebody on the phone. It could be that, our family is at a different time zone and all of a sudden you're waking up at midnight needing to talk to somebody and it's horribly in the morning for them and you would not be calling them and disturbing them. But you can go throw something out at Facebook or you can throw something out at Twitter and somebody's going to respond. It's kind of creepy a little bit that there's always people awake and liking what you say and other things, making a connection. So again, this is that idea of a lurking variable. We're not exactly sure what the cause is, but there could be other causes. But the one thing that we don't know, because there was no baseline in the study, what was their amygdalas when they were born? And do amygdalas grow over time? And if they had done a longevity study, so it was based over time, they would measure somebody's brain size and measure their social network at that point. Then we can make maybe some causes for the large amygdala and the large social network. But we can't actually make that connection at this point. But it does seem there is some sort of correlation. We just don't know what it is. Okay? So that's what you get to explore on some of your homework tonight. So look for those lurking variables. Okay? Look, don't be ridiculous. I know you guys are the what-ifers of the universe, but don't what-if everything. But just think about what logically could be a reason why there seems to be a reason why both things increase or both things decrease. Okay? Or one increases and the other decreases. All right, so that's tonight's work.